Good. So today we are going to look at rules of differentiation. And to start with, we will look at expressions of the form y is equals to ax to the power n. So when you are given expressions of this nature to differentiate, you can do so by using the relational formula dy over dx is equal to the n or the exponent here multiplies the a here, then 1 is subtracted from the exponent. So in effect, we are going to have n multiplying a, then the s to the power n minus 1. Have you seen it? The n multiplies the a, n will multiply a, then you subtract 1 from the exponent, which means that anytime you are differentiating, the exponent is reduced by 1. Let's look at examples. So if I'm having an equation of the form y is equals to 3s to the power 4. So let's look at this example. So if you have an expression of the form y is equal to 3x4, y is equal to 3s exponent 4, and you are asked to differentiate this expression y dy over dx. Based on the formula, the 4 will multiply the coefficient of x. So we are going to get 3 multiplied by 4. Then this is our s. Then the power or the exponent is reduced by 1. So in effect, we are going to have 12x to the power 3. Very simple. Example 2. If you have an expression of the form y is equals to 3x to the power 2, and you are asked to differentiate this expression, we are going to have dy over dx to be equals to the 2 multiplies the 3. So we are going to have 3 times 2. Then this is our s. Then the 2 minus 1. So in effect, we are going to have 3 multiplied by 2 will give us 6x. Then s minus 1 is 1. Very simple. Let's look at another example. If you have an expression of the form y is equals to 12s to the power 3, and you are asked to differentiate this expression, what are we going to do? We are going to have our dy over dx to be equals to 3 multiplying 12. So we are going to have 12 times 3. Then this is our x, then 3 minus 1. So in effect, this is going to give us 12 times 3 will give us 36x. Then the value of the s is reduced by 1, so we get s to the power 2. Let's do another example. If you have, so this is example 3. If you have an expression of the form y is equals to, let's say, root of x. Y is equal to root of x. And you are asked to differentiate such an expression. What do? We will change this one into the exponent form. And from indices, we know that root of a is the same as a to the power 1 on 2. So in this case, we are going to have y is equals to s to the power 1 on 2. All right. So in this case, we are going to have our our y to be equals to s to the power 1 on 2. So our dy over dx is now equal to the 1 on 2 multiplies whatever expression we have here. So we are going to have 1 on 2 x. Then we subtract 1 from the 1 on 2. We are going to have negative 1 on 2. All right. So to eliminate the negative sign in indices, we know a to the power negative n is equal to 1 over a to the power n. which means the s to the power negative 1 on 2 appearing here as a denominator will eliminate the negative sign. So in effect, we are going to have 1 on 2, then the s moves to join the 2. So we are going to have s to the power positive 1 on 2, which is the same as 1 on 2 root x. Very simple. Very simple. 2 root x because s to the power 1 on 2 is the same as the root of x. Let's go to differentiation of a constant. Differentiation of a constant. Good. All right. When you have an equation of the form y is equal to ax squared plus bx plus c. When you have an equation of the form y is equal to ax squared plus bx plus c. The c in this case is called a constant. The c is our constant. Now, according to the rules of differentiation, anytime you differentiate a constant, you get a 0. So we say the derivative of a constant is 0. Now, if you look at this equation very well, you can see that the a is having an s to the power 2, the b is having an s to the power 1, but the c is without an x. This equation here is actually y is equals to as to the power 2 plus, so from 2 we are moving to 1, so plus b to the power, bx, so s was to the power 2, this s is to the power 1, plus our c is also having an s to the power 0. So this expression here is called our constant. So anytime you are differentiating your constant, what do you get? That's what we call differentiation of a constant. So let's see. So if you are having an expression of the form y is equals to c, and in this case c is a constant, don't forget that this c is having an s to the power 0. S to the power 0. So applying the rules we have learnt here, the 0 here will multiply the c. So we are going to have dy over dx to be equals to 0 times c, then x0 minus 1. And this is equals to 0 times c is 0, then s to the power minus 1. Any number times 0 is 0, so this is going to give a 0. What does this mean? This means that anytime you differentiate a constant, the value is 0. You get it? Good. So now let's combine what we have learnt here and what we have done here. So if I'm having an expression of the form y is equals to 4x squared plus 3x plus 2, and you are asked to differentiate such an expression, don't forget, this expression is the same as y is equals to 4x squared plus 3x plus 2x to the power 0. So if you are asked to find the y over the s, or to differentiate this equation, then you are going to have the y over the x to be equals to the 2 multiplied the 4, then the exponent of the s reduces by 1. So you are going to have 4 times 2 will give us 8. Then the s is reduced by 1, okay? Plus this 3 will multiply this, the 1 here, you know this is to the power 1. This 1 will multiply the 3 here, you get 3. The s is only 1, so when you subtract 1, that is it. Now, plus 0 will multiply the 2, 0 times 2 is 0. So the whole of this side will not come, you get 0. So therefore our differential equation will be 8x plus 3. Very simple. Very, very simple. Let's look at more examples. Okay. So find dy over dx if y is equals to 2 on s to the power 3. B, y is equals to 1 over root of x. C, y is equals to 3 root of x. Then the last one, D, y is equals to 1 over cubic root of s to the power 4. Cubic root of s to the power 4. So let's see how to solve these questions. So let's find dy dx in the first case. So let's come to solution A. So in the case of A, we are having y to be equals to 2 on x to the power 3. S to the power 3. So in this case, the first thing we can do here is to send the denominator up. So in indices, when the denominator is going to join the 2, in this case, the denominator is to the power 3, positive 3. If it goes up, it becomes negative 3, which will imply that our y is equals to 2x negative 3. Very simple. We can now differentiate this expression. So in this case, we are going to have our dy over dx to be equals to negative 3 will multiply 2, we will get negative 6. Then we subtract 1 from the negative 3, we will get s to the power negative 4, which is the same as negative 6. Then since it is negative 4, it comes down as a denominator. So we are going to have s to the power 4. I hope you get it. So anytime an expression with a negative number is sends down as a denominator, the negative disappears. Let's see B. B, we are having y to be equals to 1 on root of x. So this expression here is the same as y to be equals to 1 on root x is the same as s to the power 1 on 2. Which is the same as I'm sending the x up as a numerator. In this case, the 1 on 2 will be negated. So we are going to have s to the power negative 1 on 2. I can now find my dy over dx. So in this case, my dy over dx is equals to, the coefficient of this s here is 1. So this negative 1 on 2 multiplies the 1. So we are going to have negative 1 on 2x. Then negative 1 on 2 minus 1 will give us negative 3 on 2. Okay? So that is 1 minus 1 on 2 minus 1. And that will give us negative 3 on 2. So in this case, we are going to have negative 1 on 2. Then now the s comes down as a denominator. Coming back to its original position, we are going to have s to the power 3 on 2. Okay? Now, 2s to the power 3 on 2 is the same as, so if you are having s to the power 3 on 2, this is the same as x to the power 3 or to the power 1 on 2. Okay. Then an expression to the power 1 on 2 is the same as the square root of x to the power 3. So in this case, we are going to have our dy over dx to be equals to negative 1 over 2 square root of x to the power 3. Very simple. Very simple. Next question, that is the C. C, we have y to be equal to 3 root of x. Okay. So in this case, you have to eliminate the root sign and replace it with 1 over 2. So in this case, we are going to have our y to be equal to 3x to the power 1 on 2. Okay. So if I am differentiating this expression here, then we are going to have the y over the x to be equal to the 1 on 2 multiplies the 3. So we are going to have 3 times 1 on 2. Then this is the x. Then we subtract 1 from the 1 on 2. So 1 on 2 minus 1 is negative 1 on 2. So this is going to give us 3x negative 1 on 2 all over what? 2. Okay. Which is equals to. So now our x to the power negative 2 will move down as a denominator. And as it's moving down as a denominator, the negative sign disappears. So we are now going to have 3 on 2 x to the power 1 on 2, which is the same as 3 on 2 root of what? X, because x to the power half is the same as root of x. All right. Let's solve the last question. The final question, that is D. We are having y to be equals to 1 on cubic root of x to the power 4. Y is equals to 1 over cubic root of 4. So in this case, we have to do some manipulation here. Cubic root is the same as x to the power 1 over 3. So this our equation y here is equals to. So let me do some explanation here. So if you are having cubic root of x to the power 4, in indices, if you have the cubic root of, let's say, a, then this is the same as a to the power 1 on 3. If you have the fourth root of a, this is the same as a to the power 1 on 4. In that same way, if you're having the cubic root of x to the power 4, then you should know that this is the same as x to the power 4, then the cubic root will be 1 on 3. And you know, in indices, if you have a to the power n times c, this multiplied this, so we get a to the power nc. So in this case, the 4 multiplies the 1 on 3, and we are going to have x to the power 4 on 3. I hope you have gotten it. Very simple. So we have to do this manipulation here. So here we are going to have our 1 on x to the power 4 all raised to the power 1 on 3, which is the same as 1 on x to the power 4 on 3. Okay. So with this, we can say this is the same as. Now, since it is a denominator here, we would like it to be in the linear form. So x to the power 4 on 3 goes up as a numerator, and we are going to have x to the power negative 4 on 3. So we cannot differentiate. So our dy over dx is now equal to negative. This 4 on 3 multiplies the variable here 1. So we are going to have negative 4 on 3, then x, negative 4 on 3 minus 1. And what is negative 4 on 3 minus 1? Negative 4 on 3 minus 1. That is negative 4 on 3 minus 1. This is over 1. Okay? So we are going to have 1 times negative 4, that is negative 4, minus 3 times 1 is negative 3. All over 3 times this one, that is 3. So we have negative 7 on 3. So in this case, we are going to have, let me continue here. We are going to have dy over dx to be equals to negative 4 on 3. Then this is our x, and this x is to the power, what did we get? It's to the power negative 7 on 3, or negative 7 on 3, which is the same as negative 4 all over this 3. Then the x moves down as a denominator, and in this case we are going to have x to the power 7 on 3. Final answer. Very simple. So this is how we saw these basic differential equations. These basic equations, when you differentiate them, what you get is called the differential equations. Once it is not differentiated, it is just an ordinary equations.